Hello everyone, this is Vivian Chan. Today in this video, I'm going to explain HSC Maths extension 1 question 11. So question 11 is not difficult one. Question A, it gives you a polynomial and tells you that this polynomial has some zeros. And then in question A, it asks you to show that x equal 1 is one of the zeros. So it is just you put x value equals to 1 and then direct calculation, you know that x equal to 1 is actually one of the zeros for the polynomial px. Question number 2 asks you to find all the other zeros. We know that if x equal to 1 is one of the zeros, then px must be able to factorize as x minus 1. You can use long division to factorize the x minus 1 out from px, and then further factorize the degree 2 polynomial into these two factors. So we know that x equal to 1, x equal to 3, and x equal to minus 2 are all the zeros of px. Then question B asks you to solve this log base 2 equation. It is not so difficult as well because due to log property, we know that the two log means index. The two index sum up means the two numbers multiply. Therefore, we have log base 2 5 plus log base 2 x minus 3 equals to the two numbers multiply 5 times x minus 3 log base 2. Now let's take a look of the meaning of this log base 2 5 x minus 3 equals to 3. What does this mean? It means you have a number. We don't know what number it is, but when the base equals to 2, the index should be equals to 3. So the index equal to 3. This, everybody knows that it is 8, right? And therefore, we know that this 5x minus 3 is actually equals to 8. Then solving for x is no longer a problem. It's equal to 3.6. Question C. It asks you to rewrite root 3 times sine x plus cosine x in the form of a constant r times sine a angle, where r should be a positive, and then this angle alpha should be between 0 and pi over 2. Therefore, we put these two forms in one equation, and then let's expand the right-hand side into sine x cosine alpha, cosine x sine alpha, and then multiply this r into the bracket. I try to rewrite the things in different colors. On the left-hand side, this sine x, we have root 3 sine x. On the right-hand side, this sine x, we have r cosine x. Since they are in one equation, and the sine x part should be exactly equals to sine x part of the right-hand side, and so we can write root 3 should be equals to this r cosine alpha. And then the cosine x part, similarly, we can just write the cosine x part should be exactly the same. But the problem is on the left-hand side, there is only cosine x. But right-hand side, other than cosine x, we have r sine alpha. Actually, the cosine x on the left-hand side, it means 1 cosine x. And therefore, we can have 1 equals to sine alpha. Now, our problem is what's the values of r and alpha? We have two equations, two unknowns. So to solve this alpha and r, let's try to divide these two equations. Root 3 over 1 should be equals to r cosine alpha over r sine alpha. Then here we know that on the left-hand side, we only have root 3. Right-hand side, we can cancel the r cosine alpha over sine alpha equals to cotangent alpha. Cotangent alpha equal to root 3 means alpha equals to pi over 6 in this range. To solve for r, we know that alpha equal to pi over 6, so r equals to 2. Therefore, we can get to our answer. Part D, the question tells you that there is 2 seconds from point C. Intersect the circle at 4 points, this 4, and I try to name them by A, E, B, and D for easy explanation. The question asks for the value of X, and I try to join point A and B, D and E, and you can see here we have 2 similar triangles. ABC, the other triangle is this D, E, and C. Why are they similar? Because angle C is the common angle of these 2 triangles, one in blue, one in red. And we also know that this angle A should be equal to this angle D because it is angle from the same arc, angle in the same segment. These 2 angles should be equal. In a triangle, in 2 triangles, you have 2 angles equal, and the rest, the third one, must be also congruent because angles of triangles 180, you have 2 angles correspondingly equal, then the third one must be also equal. And now we know that these 2 triangles, they are similar. For similar triangles, you can tell that the sides are in the same ratio, they are proportional. Therefore, we know that sine AC divided by sine DC should be equals to sine BC divided by sine EC. They are proportional sides. And sine AC is 2 plus X. Sine DC should be 5 plus 3. Sine BC equals to 3 and sine EC equals to X. Now solve X. Is not a problem because it is just a simple quadratic equation, x equal to 4 or minus 6. But x cannot be a negative value, therefore x must be equal to 4. In part E, there is a rational function fx equals to 1 over 4x minus 1. As for the domain, means what kind of x can be input into the function to give you some output. Here, fx is a rational function, means the denominator cannot be equals to 0, which implies that x does not equal to 1 over 4. Therefore, the domain of x is all real, but not 1 over 4. Part 2 asks to solve this inequality fx less than 1, and fx is this fractional polynomial less than 1. For solving equation, we would just multiply both sides by 4x minus 1. But this is an inequality. We cannot do that because we don't know whether 4x minus 1 is a positive number or a negative number, because it makes difference in inequality. This is not an equation. So we have to make sure that whatever that we are going to multiply on both sides of an inequality be a positive value. How to make sure that 4x minus 1 a positive? The trick is, instead of multiply by 4x minus 1, we multiplied it by 4x minus 1 square. A square real number, when you square them, is going to always a positive. All right, so if I multiply both sides by 4x minus 1 square, then this inequality will still hold. The smaller than sign will still hold if you multiply both sides by a positive number. So now in the denominator you have 4x minus 1. On the numerator you have 2 4x minus 1. Means the 4x minus 1 multiplied itself with 2 times. So we cancel out 1 and you still have 4x minus 1 for only 1 time on the numerator, but on the right hand side of the inequality it is a square term. You can expand it, of course, and then rearrange it to become a quadratic inequality and factorize it, but what's the point, right? Because you have both sides 4x minus 1, we can just factorize it directly. So now I try to minus both sides by 4x minus 1, therefore left hand side 4x minus 1 minus 4x minus 1 exactly the same, so it becomes 0. Right hand side, you have this minus 4x minus 1, factorize it out, and the first term here, since we have two 4x minus 1 multiplied together, when you factorize 1 out, you still have 1 left. So you have 4x minus 1. But on the second term here, because there is only one 4x minus 1, right? So when you factorize it out, there's nothing left. Nothing left means you have this 1 times 4x minus 1. So you have this 1 here. Then you have 4x minus 2. Factorize the 2 out, it will become 2x minus 1. 4x minus 1 times 2x minus 1 times 2 greater than 0. You can solve it by both. It only holds when both of them are positive or both of them are negative. When both of them are positive, then x must be greater than 1 over 2. When both of them are negative, then x must be less than 1 over 4. So this is the range of values of x that satisfy this inequality fx less than 1. F asks you to evaluate this integration. A fractional polynomial with a denominator in a third form. It is quite impossible for you to do this integration directly. But this is quite good because let's just ignore the third form. The numerator is degree 1x. And in the denominator, other than this third form, things inside the third form is also in degree 1. So we can let whatever that is inside the third form to be u, just like what the question is suggesting you. So now we just let u equal to 1 over x. We do differentiation with respect to x on both sides. We will have du dx on the left hand side, and the right hand side we only get minus 1. Therefore, du dx equal to minus 1 means du equals to minus dx. And then we change the upper lower limit of this integration. When x equal to 0, 1 minus 0, u equals to 1. When x equal to minus 3, 1 minus minus 3, u equals to 4. Now we get everything ready. We just transform this x into u. U equal to 1 over x means x equals to 1 minus u, right? So it is 1 minus u. And denominator, it is root u. Dx, it is minus 1 du, all right? Because du equal to minus dx, so dx equal to minus du. And the upper lower limit of x changed to u, so it's 1, 4. This minus 1 allows you to interchange the upper lower limit of the integration from upper limit 1, lower limit 4 to lower limit 1, upper limit 4. The minus 1 allows you to interchange the upper lower limit of the integration. And then this 1 minus u, the numerator part, alright, we can separate it to 1 over root u minus u over root u. U over root u, you can simplify that to become root u. And now the integration is simple and easy. The upper limit, you substitute 4 into u. Lower limit, you substitute 1 into u. Find the difference, and the answer is minus 2 and 2 over 3.